Hi, this is a chi-square example from your Political Analysis Chapter 7 book, starting with Table 7.6. So I've duplicated the crosstab in Table 7.6, and I have written key pieces of information in the table. So I've written the actual raw number of people, of men and women, who reported that they favored diplomacy over the middle, over the force category. So again, this matches Table 7.6. In my total column, I also need the information about the total percent. I don't need the information for the total percent in order to run my chi-square of the boxes in the middle. And when you're setting up a chi-square, it's useful to set it up in this way because you are actually going to be making calculations only in the middle squares and not in the total squares. So I'll repeat, you will not be doing a calculation in the total squares, either in the column, which is our dependent or our independent variable rather, which is gender, or our rows, which is our dependent variable, which is support for diplomacy or force. So I've got, and in table 7.6, I've got 99.9% down here and a little note because of missing data. We assume that this is 100% because that's the data that's the data that we're working with. All right, so let's get started with chi-square. So chi-square works by measuring what you expect versus what is actually happening. So our hypothesis for this test is that women favor diplomacy more than men. And we have the data of what actually happened. So we actually know that 245 women supported diplomacy and only 176 men supported diplomacy. The chi-square test will tell us whether this difference is significant between men and women. So we know our observed frequency. So when you're looking at the instructions for running a chi-square, the first thing you do is look at the observed frequency, or your FO. So I've already labeled the actual raw number with FO. Again, my observed frequency. So how do I calculate my expected frequency? You see in Table 7.7 a lot of calculations, but this piece is very critical. So when we do our expected frequency, what we do is go with the null hypothesis. So I'll start with the top row. So the total number of people who support diplomacy is 44.4%. If we are wrong about women favoring diplomacy more than men, they should have also 44.4% support. So the way that we calculate our expected frequency is to multiply what we expect using the total box. So this would be 0.404 times our total number of women, which in this case is 530. So we're using the total column below of how many actual women there are. And if our null hypothesis is right, that 44.4% of women and 44.4% of men support diplomacy, let's check that out to see what that looks like. So the expected frequency for men is going to be 0.404 times 511 because there are 511 men in this sample. So your total percent is what you use to calculate your expected frequency across your categories of your independent variable, but you have to multiply that by the actual total in that particular category. And these numbers will rarely be the same. So I'm going to scroll down. I'm going to push down my paper to the force column because that's the column that your chapter works through to show you how to do the math to finish out the chi-square formula. And let me go ahead and write the chi-square formula to show you what we're trying to do. So the chi-square formula, chi squared equals the sum. So the sum of our actual observed frequency minus our expected squared over R expected. And what you do is you run this calculation for each of these boxes. You do not run it for the outer boxes, which is why I made these percentages big. It's a good visual cue when you're doing your homework. Do not do this calculation in that box. But you do this calculation for every single box. So again, let me jump down to force and work through the piece that's described a little bit in more detail in your book if you want to open up and follow along. So for force, for women, we have 160 for our actual, or our FO. Our FE, or our expected frequency, is 0.339 because that is the total number of people who support force. And we would expect that to be the same for women. So we multiply 0.339 by 530, and we do the same over here for men. We multiply 0.339 by 511. And because we have the benefit of having table 7.7, the chapter is already published, what you keep doing with the math, and I'm going to go ahead and go with their rounding figures so that this matches the example in the book. So I'm going to keep going with the box of force and women. So we have an FO minus FE equals, or FE, sorry, equals 179.7. FO minus FE equals negative 19.7. So I'm subtracting 160 from, or 179.7 from 160. And then when I square that, I get 388.1. And then when I divide all of this by FE, I get 2.2. So I need this figure for every single one of my boxes. And that is the bolded figure, or bolded number rather, in table 7.7. So if I kept going for all of this, if I ran the same calculation, here's what we would get. So we'd get one number for each box. And when you get the numbers for each box, you continue with your chi-square equation. So now I've got chi-square equals the sum. So now I've got chi-square equals 4.4 plus 4.6 plus 0.9 plus 0.9 plus 2.2 plus 2.2, and this equals 15.2. So my chi-square statistic is 15.2. But I am not done there. All this does is give me a test statistic. Now I have to see if this test statistic is significant or not. And I do that the same way that I did with a t-table or t-test, and I look at my degrees of freedom. For a chi-square, your degrees of freedom equals number of rows minus 1 times number of column minus 1. And in our example, we have 3 rows because we have diplomacy, middle, and force. So 3 minus 1 times 2 minus 1 because we have men and women in columns, and that equals 2. So we have 2 degrees of freedom. So now I have a chi-square value of 15.2 and degrees of freedom of 2. Those are the 2 pieces of information that you need to see if there is a confirmation or support for your research hypothesis, because remember, we're testing against the null hypothesis. So let's see what we do next. We look at table 7.8 in your book that gives you the critical value for your degrees of freedom. So I'll just replicate really quickly. Table 7.8, our significance levels are at the top. And like with the t-test, this is a published table. So this is not something you make up. It exists. You can look it up on the internet as well, and you'll get the same data. So we are honing in on degrees of freedom equals 2, and our critical value for 0.1 of significance, or our p-value, is 4.61. Our 0.05 level of significance has a critical value of 5.99, and our 0.01 level of significance has a critical value of 9.21. So we take our chi-square value and find where it is in the chi-square table. And we go by the degrees of freedom. So I use my degrees of freedom, and my chi-square value is way over here, and it's much greater than this threshold. So my p-value, in this case, the table in your book only goes up to 0.01, so my p is less than 0.01, and this means that we can support our research hypothesis, and that there is a gender difference in diplomacy, and we can confidently reject our null hypothesis. So the null hypothesis would be confirmed, or we would fail to reject our null hypothesis if your chi-square is less than these critical values. Again, this is like the t-test that we learned earlier in chapter 7. So we take our chi-square to review, find our chi-square table using our degrees of freedom. We go across and find where our chi-square value lies, and if it's greater than our critical value, then we can reject the null hypothesis. If it's less than these critical values, so if our chi-square were a 3, then we would fail to reject the null hypothesis, and that means any difference that we observed in the crosstab would not be significant. But in this case, the differences that we observe in our crosstab are significant.